experts who will shed light on the synergies between floating and fixed offshore wind technologies and how these technologies can complement each other to drive innovation and efficiency across the industry. My name is Serene Hamsho, and I lead the American Offshore Wind Academy, which is a newly formed initiative, industry-led academy with the mission to drive and advance the offshore wind industry through providing professional training and comprehensive education. One of the industry leaders once used to call us the Uber for offshore wind knowledge, because what we're basically doing is connecting the experts together. Over the past couple of years, and I'm sure every one of you have heard this, there has been a lot of focus on workforce training that targets technicians and those who sit in the field, but there hasn't been any kind of training for those who sit behind the screens and do the actual job. Even though 5% of the projects actually has made it to the construction phase, while 95% of the projects are still in the development phase. And this is really the gap that we are trying to bridge. And I'm actually glad to see a couple of our instructors sitting here in the room also with me on the stage. And I'd like to take this opportunity as well to remind everyone that we are doing a joint workshop with UMaine tomorrow at the ASCC. This is going to be a very unique workshop because I've just learned that the people there are going to put the actual prototype in the basin and do demonstration around it. So I encourage everyone, if you can make the time to be with us tomorrow. I think we have one or more spots available. So if you are interested, you can just come to me after the panel, or you can talk with the team over there. So before we dive into the discussion, please join me in welcoming our distinguished panelists. We have Walt Musial, the NREL Chief Engineer, Katja Akentieva, the Vice President of New Energy at TGS, Jay Borkland, the Director of Ports and Supply Chain at Avangrid, Terry Shara Matthews, the Senior Vice President of the National Offshore Wind from WSP, and then we have Nina Hoffman-Vollmer, the Associate Sales Director for Offshore and Floating Wind and Vestas. Please help me welcome our panelists. This is working. Yes, it is. All right. So, Walt, I would like to start actually with you. The NREL has released the new market 2024 market report. Congratulations. This is definitely a great effort that you and your team has been working on for over the year. Could you start by giving us an overview of how the synergies between fixed and floating offshore wind can help drive efficiencies, particularly with shared supply chains and infrastructures?
Sure, and should we go to the slides?
Yeah, I think the clicker is over there, so you can use it.
Hi, good morning, everybody. So some of this I went through yesterday, and I'm not going to spend a lot of time on the old slides, but I do want to put more emphasis on some of the stuff that I touched upon, because I think it's very important that we take advantage of the whole industry and not just look at the floating industry in isolation. So, and that's what. So some of these slides may be familiar to you, but I just want to repeat this this line here. We need to demonstrate that we have market scale and market certainty in large enough quantities to attract the investment that's necessary to build the infrastructure and the supply chains that we need for this industry. And in order to lower costs, all of that has to happen kind of in unison, and there's a chicken-egg component to that. So it's very important that we look at this holistically. And so this is kind of my slide that I think I showed yesterday, but it's very important to know that, especially in this region where they're building gigawatts of offshore wind south of Massachusetts, New Jersey, down in Virginia, the 2/3 of that supply chain is related or overlaps the floating supply chain that we will soon need to build the floating industry. And so they're very much connected. There are unique components to the floating industry that we can't overlook and that we have to focus on, such as unique ports, port development, such as the substructures that are going to take up a lot of space in their development, and they have to be manufactured locally, probably. But then there's a lot of stuff that comes in, and if we want to measure the market scale and determine market certainty for meeting the state and national requirements, both globally and at a state level, we need to consider the markets for both fixed and floating wind. And so we've looked at this. This is a slide that I borrowed from Katja, who's 4C Offshore and TGS has just done this market analysis. And if you add up all the ambitions and targets and stated goals of different countries in the world, we're looking at about 807 gigawatts, which is a huge market for all of offshore wind. And you can see the countries that are there and that are involved in this. So this is a key slide because this indicates that there's a huge market that's emerging. And of course, most of this is in the planning phase and is under development still. So I showed this slide yesterday. This is the US market, but at the top, in the US market, it has been developed and characterized in terms of the pipeline that's out there, and the pipeline is what's in the regulatory process right now. There's 80 gigawatts in the pipeline right now in the U.S., and that breaks down into about 1/3 floating, 1/3 fixed bottom. So the floating industry is real and it's emerging, but it's mostly in the planning stage because we're counting the capacity of the lease areas that have gone out there, and that's going to grow as more leases get put out there, so including the leases that are about to happen. But what we're kind of experiencing here is that the level of floating that's been deployed so far, I think that might be in one of my next slides or this one, we're still down in the megawatts, hundreds of megawatts, but still megawatt scale doesn't get the supply chain excited, doesn't get the investors excited because they look at those numbers and they're pretty small. So when we compare these numbers to what's happening on the fixed bottom side, they're just it's orders of magnitude different. So I think it's important that we kind of look at this together because the businesses that are benefiting right now from the fixed bottom industry are also going to be contributing to the floating industry when it emerges. And this floating industry is likely to be something that's comparable to the fixed bottom industry in the long run. So when we look at 231 megawatts compared to 68,000 megawatts for fixed bottom, there's a little bit more interest maybe in looking at those two. And we're also seeing now that the floating market is starting to advance and become more serious, getting into the permitting phase globally. But we need to make that happen in the United States. But in spite of all that, it's still a 100 gigawatt scale pipeline for floating. But it doesn't get people excited if it's all in permitting. So we want to make sure we want to look at this deployment curve and make this kind of advancement, this hockey stick curve that's going up, and potentially 14 gigawatts by 2029 based on the announcements that our developers have made. We want to try to help make that real. So, I've looked at the different regions of the United States and calculated that we really do have a potential for a floating market that's at the same size of the fixed bottom market, and I think 7 out of 10 of the next auctions will be floating auctions. So the U.S. needs it, and is serious about doing that. So I think we're just to conclude this opening, I think we're looking at commercialization on its way, but we need to see that the cost reduction come, and in order to get that, we need commercialization and industrialization to happen at a fairly rapid pace in the gigawatt scale. And when we get to that point when, I mean, fixed bottom supply chains are going to contribute significantly to making that happen, especially on the East Coast where we're already building that supply chain. And so I think that's the topic that we want to really explore here in the synergies for how that can happen. So, oops, I went the wrong way. I think that's, I'm going to turn it over to Katja now.
All right, thank you so much, Walt. Maybe I can get the clicker, or you would like to advance the slide? Thank you, Walt, for laying the foundation. Katja, I have actually a question for you about the global scale of the offshore wind. We all know that we are 20 years behind when it comes to fixed bottom, but we don't seem to be that late when it comes to floating. So can you give us an overview and talk about how we can really catch up with the global markets, and what do we need to do in order to be competitive on the global scale?
Thank you, Serene. Great to be here today. But first of all, I actually wanted to comment on one thing regarding potential. We talk a lot about sort of where the rest of the world is on offshore wind, and I wanted to let you know that today at 4C Offshore we actually released our market outlook. We do it every quarter, and the exciting part for me personally in that release, and some of you who subscribe to it will see it, when we look at the projects and the stage of each project across the world, we now in the United States score number 3 on projects that are under construction. China and UK are leading, and United States is number 3 with 4 gigawatts, with China at 9 and UK at 5. So really exciting to see that, and that's just a change that we've observed in the last 3-4 months. But speaking of floating and the attractiveness of the market, so we at 4C Offshore actually twice a year we release this report on floating specifically. And so attractiveness index is something we put forward when we assess countries on different attributes. And ultimately, what I'm showing here is the recent report. And keep in mind, this is 3 months ago. So this is before Oregon and Maine were actually put on the lease agenda. And we're showing number 6 here. But we have a great potential to become the leaders in the floating wind. And why is that? If you look at the different scores here, and I'm sorry the slide is a little messed up, but what I'm showing here is regulatory and potential. We score really high. So potential meaning the wind, we're actually ranking number 2. This is it actually. Sorry. Oh, thank you. I can't see that slide screen. So we're scoring actually number 2 on the potential. So yes, we have a great wind, we have a great resource, and that's important in the consideration. We have the highest ambition. Walt just showed you the slide which shows United States having the highest ambition across the world on a single country basis. And then one thing that's got going for us is a very transparent regulatory framework. We have a very reputable agency who's got a great track record of dealing with energy projects. So those are the scores that we have really, really high. And then, of course, one that the deployed, as Walt showed, that the rest of the world hasn't got a lot of deployed. So right now you're seeing here Norway leading with 100 megawatts, so that's not a whole lot. On the pipeline, we have, again, a very good potential because we have a big pipeline, floating wind project that goes into the attractiveness. So really, just to conclude, one that we score really low, and we talk a lot about it in the last few days, is how do we build out domestic supply chain, port infrastructure. So we have already a great regulatory framework. We have good tax credit incentives. So really, what we need to do is develop that domestic supply chain, port infrastructure. We need to also train and reskill our workforce. And I wanted to actually give a shout out here to Serene and what the Academy is doing, because they're really putting words to action and educating our workforce so that we can be better positioned to develop that domestic supply chain and the workforce. So please give her a hand.
Thank you so much, Katja. Since you're standing here, I'm going to actually have a follow-up questions. Speaking of data and the effort that TGS and 4C Offshores are putting, how can we use these data? What's the role of these data in de-risking and accelerating the offshore wind, the floating offshore wind projects, particularly in comparison to the fixed project?
Data is my favorite subject, and as you can imagine, in the offshore wind, a lot of data is getting collected, and data that varies both spatially and temporally. So, yeah, data has a big role to play, and typically in a development stage, when you look at your site assessment, because we talk a lot about how we're going to construct those floaters, how we're going to get them out there, how we're going to operate, but what's really important is also to try and reduce our development stage, and that's where a lot of synergies between fixed and floating will be accomplished, are going to be accomplished. Similarities here. So what can you do with the data? If you collect the data early in the stage of the project, if you collect accurate data, if you collect diversity of data from wind resource to metocean to subsurface, you're able to de-risk that project early in the game. And what you do ultimately is you help your environmental consideration. That's permitting, that's stakeholder engagement. You understand your biodiversity around the lease. Technical certainty, so a lot of data, metocean data specifically, goes into the equation to reduce and improve that certainty. And then last but not least, financial certainty. That's your ability to predict your energy output. It all starts with measuring wind and observational data, because if you know your energy output, you can then predict your project potential, revenue, and that helps you to get the best financing. It helps you to have options on the financing. So all of that really helps if you have the right data, and you can de-risk that project by utilizing those types. When it comes to question fixed versus floating, so I can comment on a couple of types of data that TGS is definitely involved in collection, and we have a technology that we enable to collect those types of data. So wind metocean, so fixed versus floating. The ultimate message is the toolkit exists. The toolkits are similar from fixed to floating when it comes to data collection. Yes, there's some augmentations that need to be done, but when it comes to wind and metocean, again, you're dealing with more dynamic structure here with floating, so probably more in-depth assessment will be required. So what I'm showing here on this map is what TGS has been involved in collecting data across the East Coast, all to support fixed wind. So you can see the data collected simultaneously on a regional scale, and a variety of data has been collected. Well, we're doing the same in California. We plan to do exactly the same in Maine, with all of these types of data being collected. Subsurface, really important. In floating, you have more anchor points. So you really need to have maybe a little bit more understanding and a better understanding of that subsurface and the anchoring. So a lot of technologies exist right now. They're being applied in fixed. 3D versus 2D is one example, where you need to have contiguous understanding, contiguous image of your lease, so you don't miss anything. And today, the traditional way is to do 2D, and then you go back because you haven't covered something. So this really provides you a great deal of flexibility for your design, and in floating, that's going to be, that's really important, so it isn't fixed. So some of those elements, again, already there, and the flexibility could be provided through some of those novel technologies. That's just one of the examples of those.
Thank you so much, Katja. I'm going to come back to you with a question about these new technologies, but I'd like now to move to Jay and talk a little bit about ports and supply chain. Jay, you've been heavily involved in New Bedford terminal development and many other ports on the East Coast. I'm wondering, how can we use these ports that are being developed now, and how these ports can be adapted for floating offshore wind projects?
Okay, yeah, thank you, and great question. It's large, big scale. I think the first part of the answer is just like when, I mean, we're still in nascent stages with port development for fixed bottom offshore wind, and we did over the last few years go from one port that was developed for offshore wind marshalling to 6 or 7 now that are either already built or are in construction. So we've made huge strides along that area, but we're still have a ways to go on that, and now we're starting to talk about, you know, floating offshore wind ports, which are not quite the same animal. But one thing we learned as we went through the journey of developing fixed bottom ports is that you need a constellation of ports to build your project. If you look at Vineyard Wind 1, which is going in the water right now, as many as 7 or 8 different ports have been utilized. U.S. ports have been utilized, and Canadian ports have been utilized to meet the needs of the logistics for that project. And so we're not just talking about one port. And so ports that are fixed bottom that have limitations, for instance, might be behind bridges, so it makes it challenging for floating offshore wind. They still have a utility within the floating offshore wind genre, because there are many parts of the projects that, for instance, moorings and anchoring and a lot of other subcomponents of the floating turbines that will need port space. They'll need port logistics. So there's a significant opportunity for the ports that have already been developed for fixed bottom offshore wind to get involved in floating, and you don't need to necessarily write them off because they have a narrow channel or a bridge. We do tend to focus when we talk about floating offshore wind ports on those facilities that have no overhead restrictions, have deep water channels that are wide enough, and have wet storage. And so that's a challenge, and there are several fixed bottom ports up and down the East Coast that can be adapted to be brought into the floating offshore wind scenario, and you know, may be utilized for a portion. So there are some large port facilities that have large land areas. So one thing that floating offshore wind requires, particularly for the fabrication of the floater, the floating unit, is a fairly large land area. We like to talk about it in the 50 to 100 or multiple hundreds of acres needed. And so, you know, those fixed bottom ports that are on the large size, of which there are several in the U.S., will probably fit the bill for that kind of development. And there are new ports that are being that are on the docket for and are in design for new offshore wind, floating offshore wind ports that can be utilized for that. But there's some significant synergies between the larger ports and what the floater development can be utilized, and then the integration port. If we think of back when we got involved in fixed bottom ports here in the U.S., we went and talked to our European colleagues, and they said, "Oh, you need one port. You need an Esbjerg. You need one port, or a Bremerhaven, or a Hull. You need one port that has hundreds of acres and you can do everything at." And we, of course, didn't have that, except in very rare cases. So we developed a process where we use multiple ports, similar to what we're doing with Vineyard Wind 1, to aggregate the services and the activities to make it happen. We feel that that's probably going to happen also with floating offshore wind. And that means that ports that are being developed, for instance, we're involved in the development with Crowley Offshore Wind Services, in a port in Salem that's going to be used for the integration of turbines for the marshalling port for turbines for the future, our New England wind projects. And that port can also be converted into the integration port for providing and stepping the turbine components onto a floating unit. But there's not enough land there, and the water quayside interface isn't sufficient for the development of the entire floating turbines. So the floater, we conceive will probably be built somewhere else, and then floated down and integrated in Salem, and then wet storage. So it becomes a little bit more complicated, but it's the same complication we had to deal with fixed bottom, and it's certainly a problem that's doable. But I will say this again and repeat it over and over and over again. It took us more than 10 years to get the fixed bottom port solutions just up and running. They're not even on plane yet. We need to start with the floating now. We need to get that moving ahead immediately if we expect in 10 years to have the infrastructure that's needed 10 or 15 years to make floating work.
Thank you so much, Jay. I'm curious to learn about the additional upgrades you just mentioned in order to scale up, and the scale actually of these upgrades. You always say that here in the United States we love bridges, in Europe they love canals. So I'm just wondering around these additional upgrades you just mentioned. Can you share some of these thoughts or
Well, what's interesting when you get to the playing field is maybe a little more level than fixed, because yes, the Europeans have the European market has a lot of canals and other things that limit some of the use, but they've overcome that for the most part with their fixed bottom. And we like bridges here in the U.S. We put them everywhere. But the canals are also too narrow in many cases for the floating offshore wind units that we're talking about. So the playing field is a little more leveled, and the Europeans are now, I'm finally hearing from our European colleagues saying, we're having a really hard time finding ports for what we're trying to do with the future of floating offshore wind. So yeah, there are limitations, but you know, there are also a lot of components, and as we drill down and peel the onion on the layers of what is going to make up floating offshore wind, the opportunities for those ports that have limitations are going to be overcome for certain elements. So, you know, in California, when we were looking at the ports, the Port of San Francisco really wanted to play, but they have a couple of famous bridges, right? So it made it very difficult to see how fully integrated turbines could be developed in San Francisco. However, they have great shipyards that can produce lots of subcomponents, and you know, there's collars that need to be put onto these to connect these units. There's cabling, there's mooring systems, and all of those things. So multiple ports can play in this, and it's not a you know, one port wins all.
the multi-port strategy, as always. Thank you so much, Jay. Probably I'll come back to you to ask about oil and gas and how we can leverage from this industry. But I'd like to move from supply chain to the commercial scale development. And I'd like to ask Tirshara, could you share some insights on the major areas of focus for commercial scale floating offshore wind development?
Yeah, so this morning, the president mentioned the workforce, and that's one of the things I wanted to talk about. It's so important to build out a significant workforce to construct and install floating wind in ports, utilizing the local universities and colleges. And so what they're doing now in the Gulf of Mexico is that the University of New Orleans is actually adding a few classes to some of the engineering programs so that the students will have certification in offshore wind. The other thing is that Nunez Community Colleges is providing incentives for those students, providing them at $5,000 to take these additional classes so that they can become certified wind technicians. So these are some of the things that you all can consider for floating wind. Also utilizing talent that has been trained and fixed bottom to also come over and cross-train over into floating and to train those local talents. So those are some of the things that need to be considered in the workforce development place that we're utilizing in the Gulf of Mexico. Provide that continuous transparency and certainty around the permitting regulatory process regarding the requirements for the ports and other processes, easing that approval process and to help plan that strategic planning. I was formerly with the Bureau of Ocean Energy Management. I managed the Gulf of Mexico Renewables program in the Gulf of Mexico. So just understanding how can you best streamline those processes to get this process moving a little faster and quicker and make it easier on those willing developers. What I'm seeing now being on the consultant side is that money is the main factor, you know, and when you work for the government, you have your mission and you're trying to determine, you know, accomplish that mission. But now that you have to look at the dollars, how can you best lower the cost? And so these are some of the things that you need to consider. And also grow that service fleet, taking those things in considerations, those service vessels that have to go out and do the maintenance and have to put the crews out. how can we best grow that and utilize that fixed bottom synergies that we already have locally. And what's near and dear to my heart is to continue to build those relationships with communities in the region. I know a lot of times you say we did a lot of community service, a lot of stakeholder engagement, but it's actually continuing to go out and inform these communities, because the process is long, and a lot of times they don't understand where we are in the process. So that continuous stakeholder engagement is very key.
Thank you so much, Tershara. I'd like to move to Nina and talk a little bit about the WTG and the supply chain. Of course, when we talk about supply chain, first thing comes to mind is the hull, the floater, but the next component in line is the WTG. Before the panel, it was 50 megawatt. I'm not sure after the panel how much it's going to be, because looks like the rotor change every day and get bigger in size. But let's start by talking about how can shared supply chains between fixed and floating offshore wind projects drive efficiencies and reduce costs for both.
Yeah, so first of all, after this panel, it's still going to be the 15 megawatt. That's also what I said on the panel that was yesterday as well. And I will explain some of the reasons here. So as Walt also showed on his slide, as Walt showed on his slide, the turbine is the same on fixed and floating. It's the rotor and nacelle that is the same, and the tower is always something we design site specifically for each project. And also, we know that the tower we need for floating is a different tower than we need for the fixed bottom, because we need it to be heavier and more stiff, have more material of the steel in order to overall have a more optimized structure for the project to reduce the LCOE. But coming back to the rotor and the nacelle, it's the same supply chain, same suppliers, it's the same R&D, the same resources, knowledge and expertise. And the benefits from that is that we can achieve the scale, the economies of scale. It also means that we can achieve faster deployment, because you don't have to use the same R&D resources to design something else and wait for that timeline, that certification plan to end. So you eliminate that risk of delays. And also you ensure that it's proven technology as well. So this way you can capture the learnings from the fixed bottom wind projects, take those learnings and feed them back into the design you also have for floating. So those are some of the benefits.
Thank you, Nina. I have actually a follow-up question, because you just touched point on the WTG and the differences between the fixed and floating. When we talk about the adaptation, when we talk about the WTG between fixed and floating, the first thing comes to mind is the controller in terms of what type of adaptation. But could you just tell us what other kind of adaptation and differences between this same WTG that we put in fixed to floating?
Yeah, so we've talked about the importance of data, and already now from our demos, we have some learnings that have led us to understanding that we need a variant that is suitable for floating. So still within the same RNA, as we say, the rotor and nacelle type certificate, but with small adaptations. And one example is really practical when we've had these turbines out and they are in this floating environment. Of course, they don't tilt like this, they more tilt like this. We have oil tanks in the nacelle, and we have sensors, which are placed in a way that when they are having more movement, their alarm goes off and says that there's no oil in the tank, which then, of course, means we need technicians out there and check, is there no oil in the tank for lubrication? So, yeah, we need to just adapt to make sure that that sensor is in the right place so the alarm doesn't go off. And then we continue to get more and more learnings that we need to capture to have a floating variant of our V236 15 megawatt turbine. And I also just want to, I can also explain how it has evolved in offshore fixed bottom. So first we took an onshore turbine and we took that out in the water. And then we quickly realized we need to adapt it to a more marine environment. So that it works well with the vessels out there and the fishermen and everyone. It needs to be adapted to that. And then in 2014, we realized we need to actually design the turbine for offshore. So it has a better connection with the foundation, the TB, the platform, evacuation routes. So that's the third phase that we're in with fixed bottom. But with floating, we are taking an offshore turbine, putting it in a fixed bottom into a floating environment. And then now we're getting into that second phase of then adapting it to a floating environment, like I explained. And of course, there can be a third phase, but that's not where we're at right now. We need to have that same supply chain, achieve that scale and industrialization, so we can reduce the LCOE, and then we can look to further innovation later.
Thank you so much, Nina. You touched on the importance of data, so I'd like to go back to you, Katja, and ask you about this specific questions about new technologies. How can these new technologies, probably speaking of AI, IoT, digitization, how are these new technologies can significantly reduce project costs and in the floating offshore wind?
Thanks, Ian. So, hello. I think when it comes to novelty, it's always going to be about how can we reduce the cost? How can we reduce the costs and improve efficiency? So when it comes to development stage or site assessment exercise, for sure, we're already seeing a rise of autonomous vehicles, for example. So that's efficiency, that's safety. There's companies like Ocean Infinity, Exocean. There's a number of applications already here in the States that we see. So we think that's gonna evolve, that's gonna improve, and at the same time, data integration. Integration is key. So if you're able to collect data from the same platform, whether it's a floating buoy and you can attach different equipment without having to bias it. Rob taught me a few things yesterday with Hull. At the same time, collecting this novel 3D approach. So the seismic data collection, again, a technology that exists in the oil and gas and been utilized for decades. We're able to reduce the whole cycle by providing best image upfront, over 50% overall reduction of your geophys geotech. So that's significant impact, not only on your ability that you don't have to go out again to collect the data, but also you can bring certain information into your geotech and reduce the scope of your geotech. And that takes, again, a few years, potentially a few seasons out of the equation. I think floating will have a lot of AI applications because we have just another dynamic element to it. So all of those things will have a significant impact, I think, again, on our ability to reduce that development cycle, and that's going to be pretty critical, I believe.
That's super interesting. And I think I've seen a poster out there, one of the posters about the application of AI in floating offshore wind technology. So I encourage you to take a look at these posters in the hallway. I'd like to come back to you, Jay and Walt, and talk about ports again, because as Hein yesterday mentioned, no ports, no offshore winds. We've heard that a two-pronged approach will be needed, existing supply chain and a new supply chain. How do you see this importing or these impacting ports on the East Coast? This is the one question, and the follow-up questions. How can we leverage from the oil and gas when it comes to floating that specific component? So can you speak to these two questions, please? You want to go first?
So yeah, there's a component of this development that has to be unique to floating, and I think that's your question. And so the component of floating that really is different is that and we just went out and looked at some of this. There's dozens of ships out at sea that are doing work for fixed bottom projects. A lot of that labor, probably most of that labor will come to the port. So the port has to be bigger. The port has to have more. There'll be more jobs at the quayside than there will be for fixed bottom. And there's a heavy lift crane that has to be there to assemble everything so that the whole structure can be commissioned and towed out. And so there's a big change there that has to happen, and that those investments may be larger for the floating ports. And as Jay was saying, there's adaptations that maybe can be made to some of the fixed bottom ports, but there's also going to have to be unique floating ports and substructures that get manufactured at some of those ports, not necessarily at the ones that we do the staging and integration. I'll let Jay continue.
Yes, thanks. And you know, NREL is currently studying these factors and will incorporate them into their future reports for as they get into more and more data that's useful for floating offshore wind. But there's a couple of this is where we start to interface the supply chain with the ports, and maybe more importantly, in the past, in the fixed bottom, the ports are used as a place to park the components, pretty much, at least the U.S. ports. The marshalling ports, and then, you know, the O&M ports are obviously a little bit of a different animal. But when we start talking about floating, there's both the challenge and the opportunity. The opportunity, of course, is to centralize more of the supply chain and the workforce and the local content, because the manufacture and fabrication of the floating part of the integrated floating turbine, it can be and probably needs to be very intensely local. And we have looked at both when we were looking at the West Coast and now the East Coast floating offshore wind market, we've looked at, you know, things like towing distance. For a fully integrated turbine, do you really want to be towing that all around the world? And while in theory it's possible to tow these long distance, when you start to add the cost factor and then the fatigue element, it may be only a small amount of movement that the turbine experiences while you're towing it, but that small amount of excitation can take years off of the lifespan of your turbine just by towing it. So a 1 month tow can knock down several years off the expected lifespan of some of the components in the turbine, because even though they're moving a small amount as the towing is going on, that small amount is multiplied by the excitation that occurs when, you know, you have a turbine that's hundreds of feet up in the air. So we don't tend to think about those things. We look at where's the land, where do we have space, but when you start thinking about towing the fully integrated turbine, suddenly it becomes, you know, a multi-hundred million or billion-dollar exercise to tow them over long distances. And so local integration ports are probably going to be developed that are close to where the wind farm areas are, but they are oftentimes may not have the full land area or capacity or supply chain to fabricate the floating aspects. So that's why we sort of say there's probably a integrated port solution that ends up as part of this. And if you're developing your floating turbine in, you know, a far northern port, and you're looking to have it towed to, say, the future floating offshore wind in the mid-Atlantic, you have to factor in the cost of that floating. And, you know, people talk about one of the advantages of floating is that you can disconnect and bring the floater back to the port for maintenance or repairs as necessary. That's a very simplified approach, or a very simplified view of what becomes a very complicated scenario. And sort of dragging these things all over the world is probably not what they're made for, right? They're made to be moored and sit and produce power in a location. So there's those challenges, and then added by the challenge of we're talking, if we do end up going with concrete, which is looking quite likely here on the East Coast, and UMaine is pioneering some of that forward-looking thought process. The weight of the units is 4 or 5 times that of any of the fixed bottom I mean, if you think a monopile is heavy, wait till you see the weight capacity or the weight statistics for the floater on the concrete floater. So that makes great challenges for getting that floater from where it's going to be fabricated on the land into the water, and it's different infrastructure that's going to be needed. So there's going to have to be an add-on to the infrastructure that is being developed right now for fixed bottom. It's not as simple as, you know, just getting a bigger ringer crane. It's probably a roll-on, roll-off type with a semi-submersible or what, you know, we sometimes call elevator barge, working to get these large units, heavy units in the water. And that's just to get the first pieces moving. So, and then the last thing is to just talk about the serial production, right? Right now we're talking about producing 1, 2, 3, maybe 5 floating units at a time for these demonstration projects. But think about how many thousands of turbines will be put into the ocean for the eventual build out of floating offshore wind. And even an individual floating project is going to need, you know, 30, 50, or 100 units. That's serial production of really large components, and you need them to come off that production line, we'll call it, you know, every month. So that's a tremendous amount of production. That's a huge strain on the supply chain that has yet to even kind of wake up to understand that they're going to be in this, that there's huge opportunity for them in this industry.
Thank you so much, Jay. And I just want to comment on the quantity and the size of these components and how heavy they are. Probably one piece of this chain is probably bigger than this stage and all of us, obviously. The other day we actually did a back of the envelope calculation just to see how much of these chains do we need in California, and we found out that the length of this chain is over 2,000 miles, which is basically similar to the distance from San Francisco all the way to Washington, D.C. If we are to use shared anchored, the size came down to over 1,000 miles. 1,000 miles is basically the distance from San Francisco all the way to Vancouver. So those are huge components. So this is probably one of the differentiators between floating we use in offshore wind versus oil and gas, where they only have 1 or 2 floaters versus hundreds of floaters we have in here. I'd like actually to conclude with Tirshara and just talk about the next steps to continue advancing commercial scale floating wind in the offshore wind. Can you speak to that, Tirshara?
Yes, thank you. So we have to continue to engage manufacturers in the state. As you mentioned, local content is going to be very important about these tremendous opportunities, because a lot of times these manufacturers don't realize the opportunities. They think it may be something like a one-off type thing. And so for them to better understand the opportunity there, as I mentioned earlier, continue to engage those stakeholders about where we are in the research process and also where we are in the sale process, the commercial process, because stakeholders, they don't understand the process. We're in it every day, daily. And so for them to better understand that these are 2 separate things and where we are in those processes. Also to continue to understand the economic and engineering drivers that for these siting decisions, looking at those development costs, understanding how the cable routing cost and energy pricing, how does it all work together? So those are some of the next steps that I think that needs to happen.
Thank you so much. I'm not sure if we have time to take some questions from the audience. Maybe we can take 1 or 2 questions. If you have any questions for our panelists, you can ask them now. Any question? All right, so if no more questions, thank you so much, our panelists. Please help me thank our panelists. It was super informative panel. Thank you so much.